enthalpy of neutralization, and this is a practical for O-level new curriculum. Enthalpy of neutralization, we can define it as the heat change that occurs when 1 mole of an acid reacts with 1 mole of a base to form 1 mole of water. Ionically, we can represent this by writing 1 mole of hydrogen ion plus 1 mole of hydroxyl ion, giving us 1 mole of water plus the heat. Now, since I've said plus heat, it means the reaction is exothermic, meaning the heat to be produced to the surrounding. We expect the temperature to rise when we use a thermometer. Now, the trend of the temperatures that are going to be recorded in this experiment are going to follow a trend, in that if I plot temperature of the mixture against volume of either acid or base added, this is temperature, when this is volume of the independent variable, I'll have an increase in the temperatures and later we shall have a decrease. Why do we have the first increase? It is that the acid or the base will not be completely neutralized. Then when we reach the neutralization point or the end point, then we shall have all the acid or all the base reacting, and later we shall have a decrease because we shall be adding the independent variable, which will be in excess, and it will cool the solution. Now, we shall be using a thermometer, but the thermometer is recorded to 0.0 or 0.5, meaning the value I expect the values to be maybe 26.0 degrees Celsius or 26.5 degrees Celsius. We cannot have 0.1, 0.2, 0.4. Now, in this experiment, I've got some data which we are going to use to first understand, then later we shall have the hands-on. I have my BA1, which is the acid, at 26 degrees Celsius and the base at 27 degrees Celsius. Remember, in our experiment, we need what we call the variables. We have the independent variable, controlled variable, and the dependent variable. Now, the dependent variable, since we talked about heat being produced to the surrounding, how are we going to measure this heat produced to the surrounding? That is by determining the highest temperature of the mixture, meaning this is going to be my dependent variable. It is my interest as the researcher, it's what I will be recording in my table as results, so that I can either reject or accept my hypothesis. So what I'm having here, this is our dependent variable. Now I've decided to make sure I add different volumes of BA1, which is the acid, to BA2. It means what I've decided to change or to add particular volumes, but following a logical sequence, as you can see, 0, 5, 10, multiples of 5. This is going to be my independent variable. So I decide to vary BA1. Now, it means I have to make my my controlled variable, that is B, volume. It's going to be volume of BA, volume of BA2. Now, volume of BA2, I'm going to use 20 cubic centimeters. Now, it means I have my BA2 already. I make sure for each experimental setup here you are seeing, I'll be adding my 20 of BA2. But remember, the initial temperature of BA2, it is 27.0 degrees Celsius, meaning at 0 BA1 being added, I'll put the temperature, the initial temperature of that is BA2 in my table, which is the base, at 27.0. So at 0 of the independent variable being added, I'll put the temperature of the controlled variable in the table. Then for the others, what I'm going to do, I'll be picking 20 of BA2, then I'll add 5 into BA2, then I'll start using a thermometer, then I'll get the maximum temperature, which was 31, 34, as you've seen here. Now, what I'm supposed to do after getting these results here, I have to make sure all of them have the precision of the instrument. That is, I should follow the DPs and how the instrument's result or readings should be looking like. Then from there, I'm supposed to analyze. I'll plot the graph of temperature of the mixture against volume of BA1 added, and after plotting, I've got the maximum. This is a peak. I'll show you in another series how to deal with the results which don't give you a peak. Now this is my T2, then my T1, this is the initial, this is my T1. Now, after getting the highest, I also have to obtain this volume, the volume here of the BA1. Remember, for the other ones already fixed at 20, I know it, but I don't know the volume of BA1 that is required to completely react with BA2, and this is 15 cubic centimeters. Now, when I go to deep analysis, I'm supposed to know that heat produced equals to MC delta T. This M is mass of the solution. Now this mass of solution, it is the volume of acid plus volume of the base. Remember, I'd fixed my BA2, which was 20 already. It was my controlled variable. Then I read the volume of BA1, which has reacted to give us the very highest temperature on the graph, and it was 15. And this gives us, this is 35 cubic centimeters. Then, but remember that mass equals to volume times density, which density is 1 for water, so 35 times 1, it will give me 35 grams. Now, I have to also obtain delta T. Delta T is T2 highest, obtained from the graph, minus T1 for my table when 0 of the independent variable is added to the controlled variable, and this is 36 for my graph. I've seen the highest was 36 minus 27, and this gives us 9 degrees Celsius. Then I come here and remember C, it is 4.2, it's a constant. Now our heat produced during this reaction equals to, it is 35 times 4.2 times 9, and this gives us 1323 joules. Then I assign a negative because the reaction is exothermic, or I can simply divide by 1000 to put to make my answer become negative 1.323 kilojoules, like that. So it means for my reaction, that is neutralization, using my results, the enthalpy of neutralization is negative 1323 joules, simply because the reaction is exothermic. That's why I've assigned a negative. So subscribe, stay tuned, like and share my video. The next video I'm posting to be about enthalpy of displacement. Shalom.